Real numbers. Real numbers includes three kinds of numbers: positive, negative, and zeros. Positive numbers, for instance positive 2, when you square a positive number, you get another positive number. When you square a negative number, you still get a positive number. When you square a 0, you still get a 0. We can see that all real numbers squared is always not negative. We can say that as x squared never equals minus a. This is only true if x is a subset of real numbers. Now let's look at imaginary numbers. Imaginary numbers. Mathematicians have made a unit called I, and when I is squared, by definition it makes -1. I is also called the imaginary unit. They have also squared both sides and made another simple equation. It is called I equals root minus 1. The upper one is the original one, but the bottom one will be used often because it is simple. This may conflict with the original idea of real numbers. It is called imaginary for a reason. This number does not exist. Reason. This does not exist. You have to know that this is a separate system of numbers. Okay, let's look at some questions. What happens when we square root -4? Let's first find out what happens when we square root a times b. We can split it into square root a times another square root b. Let's apply it to this situation. Square root -4 is actually -1 times 4. So we can say that it is -1. So it's, when you do these kind of questions, we divide it into negative parts and positive parts. We can divide this into square root -1 and square root 4. Square root -1 is, as we know, it's I, and square root 4 is 2. And the coefficients go first, so it's 2i. Easy. Now let's look at another question. Square root minus a. No, this is actually a general formula of square root minus a. When you square root minus a, you can divide it into square root -1 and square root a, and then you get ai. No, actually it's square root ai. Do not confuse this. This is very important. It is not a times I. It is never ai. Just delete it off your mind. It'll never come out. Red for like, yeah. Square root -3 and square root 2. The far right one is actually too hard, so I'll skip it. Okay, we can say it's square root -3 is, of course, it's square root 3i. Pretty obvious because we said that before. And then it's square root 2. Just carry it over. Let's put the coefficients first. Square root 3 times square root 2 times I. And remember that square root AB thing? Well, we can apply it backwards. In this case, A is actually 3 and b is 2. So it becomes square root 3 times 2, which is square root 6, and I. The answer is square root 6i. This one's pretty complicated. Okay, what you must know is when you do square root minus a over square root b does not equal to square root minus a over b. This is true only when square root a is actually positive, so you must change it into a positive form. No negatives. Okay, square root 2 times I. We already know that. You should know it too. Square root 3, and then we separate the I. It's on the denominator, so you can take it out. So that it becomes 2 over 3, because it's separated, and then I. Simple. And this will skip. Find x where x squared plus 81 equals 0. That's pretty easy. X squared equals 0. X squared equals minus 81. I carried over the minus 81 plus 81, and then isolate the x, and then I square both sides. Remember that you have to put plus minus when you square both sides, and then you get root minus 81. It seems complicated, but let's simplify this out. Slowly, plus minus square root minus 81 times minus 1 would square root minus 1, which is I. Just to make it clear, plus minus 9 times I. Easy. You have to know that quadratic equations always have two answers, whether it's imaginary or real. When you plot this into a plot or whatever, and let's put this 0 into a y, and then let's look. This actually like never touches the x-axis. That means it has no solutions. But as you can see, it has a solution, which is 9i plus minus 9i, which is kind of imaginary, I guess. So, well, that happens when you get imaginary answers. You don't like you can't see answer, but and it's called imaginary root because it's imaginary, but it's also a root. Yeah. Thanks for watching. Hope you learned about imaginary numbers. Thanks.